In this quick video, I'm going to go over double replacement reactions. So the way you're going to know it's a double replacement is when you have a compound plus a compound, which just means you have multiple capital letters in both of them. When you have this, what happens is the first thing on this side and the last thing on this side are going to combine over here. So we're going to have Ag with Cl, and then the insides are going to come together. Now notice I'm putting a square around NO3 because this 3 is part of the polyatomic, so it goes with it. If it wasn't part of the polyatomic, you wouldn't put it there. So these two are going to go together, but it's not NO3H. You see how NO3 is coming after the Ag and the H is coming before? That means H has to come before this. So you got to keep the same patterns that you're seeing. Now, every time you write a compound, you need to look at your charges. Silver is a transition metal, but it actually only ever has one charge, and it's special. It's that +1. Cl is right here and has a -1, so we're good with the way those are written. H is right here and has a +1. And NO3 is a polyatomic and has a -1. So these are all even. I don't have to worry about it because they're all ones, and so we're actually mostly done. Now, double replacement reactions can have what is called a precipitate, and you have to use your solubility rules to figure that out. Now, our first compound we're going to look at was that AgCl, and you look here for either Ag or Cl, and I see Cl right here. So Cl is normally Aq, which means it is not a precipitate, unless it's with Ag, Hg, or Pb. So it could be with anything else on the periodic table, and it would be Aq, but because it's with Ag, it's going to make it insoluble, so you're going to put an S. That S is the precipitate that is formed. It's a fancy chemistry word. Now, HNO3. NO3 is right here. NO3 is always soluble AQ unless there's no exceptions. So that just means it's going to stay AQ. And then you're done. As long as you have an S here or an L for water, you're good. All right, so let's try it here. So just like I circled the first one here, I'm going to circle the first one here. Circle the last one here. I'm going to circle the last one here. Now this is a polyatomic, so the whole thing, not just the O. Okay, so your Fe and your CO3 will go together. Fe is a transition metal. You can figure out the charge from here, or you can just ask me. It's +2. And CO3 is a polyatomic. It's -2. Now, if they're both the same, they cancel each other out, and we just leave it alone. Now, the insides are going to go together. Notice I did not put the box with the 2 because this is not part of a polyatomic, so the 2 does not go. Same here. So my K and my Br are going to go together. Now K has a +1, Br has a -1, so it's actually good with the way that it's written. For the solubility rules, Fe does not appear. CO3 does not appear. That means we assume it's insoluble, which means it is an S. KBr. K is an alkali metal. It is AQ with no exceptions, so it's AQ. Now that's a lot to the double replacement. What I'd like you to first focus on is just putting the right compounds together, and then go back and focus on the S and the AQ, because the majority of the double replacement questions are S and AQ. Are not S and AQ. It's about putting the right things together.